Our lesson today is on probability. Probability can be defined as the likelihood of something happening, or the number of desirable outcomes divided by the total number of possible outcomes in a situation. There are two types of probability, theoretical and experimental. Theoretical, and both of them in fact have a more complicated definition in the book and in other sources, but an easier way to remember this is that theoretical is what you expect to happen based on math. So you have figured something out and you have made some calculations and figure that this is what you expect to happen in a given situation. Then you go to do some trials or a simulation experiment and you find out what actually happens. And so we actually do something here and we find an experimental probability. And they're not always the same. Our experimental probability of flipping a coin 100 times, that we would predict that we would get 50 heads, 50 tails. But what actually happens is usually something slightly different. Occasionally we get 50 and 50, but we might get 45 and 55. So that would be experimental probability, what actually happens when you do a simulation or an experiment. Probability is about chance, not choice. If someone offers me some candy and I look in the bag of candy and I reach in and pick a particular one, then what happens is I'm choosing. That has nothing to do with probability. Now if I reach in and don't look, then I could figure the probability of picking a certain flavor or color of candy. So it's about chance, not choice. If we're choosing something, then probability doesn't apply to that situation. Another definition you need to know is sample space. The sample space is the total number of possible outcomes. We got some examples today. So the first example, 3 pairs of pants and 5 t-shirts. So maybe one morning you get up late for school and you decide that you're going to pick an outfit without turning the light on. You reach in and you take 1 pair of pants and you reach in and take 1 t-shirt. You're not looking, you're not choosing, you're not deciding what goes together, you're just picking randomly. So we have 3 pairs of pants to choose from and 5 t-shirts, which gives us a sample space of 15. That means there are 15 possible outfits we can make with those clothes. Another example is we go out to eat and we have a choice of 3 meats and we are to choose 2 vegetables and we have a choice of 4. And so our sample space here is 3 times 4. Now, what we put next depends on if we're allowed to pick a double helping of a certain vegetable. If I'm allowed to choose between green beans, corn, and some other things, if I want double corn, then I would have, and still have the choice of 4, and this would give us 48 different meals that you could have. Okay, 48 meals. Now, it changes slightly if we can't have a double helping of something. We have to pick separate vegetables. Another thing that changes is, in this case, is there a difference between picking a meat and then having green beans and corn, or corn and green beans, or is that the same meal? Because if it's the same meal, then we've got to adjust our probability and our sample space for that. So that there's a few more things than just figuring exactly the sample space for that. But we'll look at that type of thing later, how to adjust on some of this stuff. All right, our third example then is rolling 2 normal dice. A die has, or a number cube as they're often called in books and texts, a number cube or a die has a 1 through 6. And so you would, for the first die, have 6. You could get a 1 or a 2 or a 3 or a 4 or a 5 or 6. And then once you've rolled that, you also have 6 choices for the second one. So the sample space for rolling 2 dice is 36. There are 36 ways to do it. Most of the time when we're doing these experiments, we have different colored dice. So a 5 and a 4 is not the same as a 4 and a 5. That's why we have 36. Okay? So one way we can show this, if we're not sure how to calculate these sample spaces, we can draw what's called a tree diagram. And this helps us to figure out all the possible combinations and ways we can do this. So for a dice, I would have a 1, or a 2, or a 3, a 4, a 5, and a 6. And I haven't did that very well. Need a lot of space sometimes for these. It's not very easy to draw these when you have a lot of outcomes to this, but I think you'll see the point. Alright, once I've rolled the first dice, then the second dice comes out, and it could be a 1, 2, 3, 4, 5, or 6. But if the first one was a 2, the second one could be a 1, a 2, a 3, a 4, a 5, and a 6. And if I continue that down, there's 6 here, 6 here, 6, 6, 6, 6. You can see where we get the 36 possibilities for a dice. Now, tree diagrams go horizontally. Sometimes when we're doing a prime factorization, we'll do a factor tree. We'll have a 7, which is a prime number, and we'll do this. That's a prime number, 4, 2, and 2. Those factor trees go vertically down. Our tree diagrams usually go across horizontally, and as I say, you kind of have to plan out how to draw them. You know, I need to start that 1 up, and I need to allow a lot more room for these. Certainly, if I was going to roll a third dice, it would be very hard to fit in here. And then I would add another layer on. So that's a tree diagram. Sometimes if you're not sure how to figure it out, you don't always have to draw the whole tree diagram. Sometimes just by starting it off and then doing another layer here, it helps me see that, oh look, on every number I have 6 possibilities. And so I don't actually have to finish it. I just know 6 and 6 and 6 and 6 and 6 and 6. And so I have a total of 36. And that way we can sometimes use them without drawing the complete thing. One of the things we are going to do is draw complete tree diagrams. So today we've looked at probability, what is it, what is sample space, and we've looked at some examples of different sample spaces and looked at tree diagrams. So this concludes our introduction to probability.